In this section, you will study the techniques for sketching the graphs of the sine and cosine functions. Because the sine and cosine functions repeat values continually in a regular pattern, they are examples of periodic functions. Hello, my name is Tom Atwater. The best way to understand the behavior of the sine and cosine functions is to look at their graphs. To generate the graphs of the sine and cosine functions, we will begin with the unit circle pictured here. What I want to show you is we're going to trace out an arc length S starting right here at 1, 0. And we're going to, here's our arc length S, and what I'm going to do is take you through the values 0 up to pi over 2. And we're going to look at the value of sine of S. Remember, sine of S is the y value. So what happens? Well, as I start to move along the arc of the unit circle, my y value is beginning to increase. And that's why I've written here increasing from 0 to 1. Because when we get right to pi over 2, we'll see that the sine of S is equal to 1. Well, what happens as I continue beyond pi over 2? What I hope you can see is that the y values will begin to get smaller and smaller until we reach a minimum value here of 0. And that's what's happening here. We're decreasing from 1 to 0 as we moved from pi over 2 to pi. Well, what about as we move from pi to 3 pi over 2? In other words, in this direction. Well, this time what happens is the y values get more and more negative, which means they get smaller until it reaches its minimum value, this time of -1. So in that quadrant, it's decreasing from 0 to -1. And finally, as we move from 3 pi over 2 to 2 pi, you'll see that the y value will increase from -1 up to 0. And so as we move in this direction, the y values are actually increasing in the sense that they are getting closer and closer to the value of 0. Whoa, that was great. Now that's just the sine curve. And remember that once I get back to that point of 2 pi on the unit circle, I've also therefore returned to 0. And if we were to continue going around the circle again, we're just going to repeat those values. That becomes very important when we go to look at the actual sine curve, which we'll do in a moment. But before I do that, what I want to do is look at the cosine and take you through the same exercise that we just did, which is to go around that unit circle and trace out now cosine S, which is the x value. So let's do that. All right, the same idea applies. I'm going to start here at 1, 0 and trace out the arc. This time we're interested in cosine of S, which is the x value. So what I would be looking at are the horizontal values, and I think you can see that what's happening is we are decreasing from its initial value of 1 down to where the x value is 0, right at pi over 2. As I trace out this section from pi over 2 to pi, what's happening is the x value is going from 0 to -1. So it is decreasing from 0 to -1. What about from pi over 2 to 3 pi over 2, which is this section? In this case, the x value starts at -1, and it actually is increasing as it gets to this value where it is 0. So it's increasing from -1 to 0. And in quadrant 4, that is this section, 3 pi over 2 to 2 pi, the x value increases from 0 all the way to 1. Okay, great. Now, let's actually plot the sine functional values on the coordinate graph in the xy coordinate system using these key values. We will use x for the arc length of s, and the values for y will correspond to sine of s. All right, so here we have specific values that we were just looking at. For example, negative 3 pi over 2 is equal to 1. So if we look along the x-axis and then go up to positive 1, we see negative 3 pi over 2, comma 1 would be right here. Negative pi, comma 0. So go to negative pi and land at y equals 0. Very quickly then, negative pi over 2 is right here at negative 1. We're going to pass through 0, 0. Pi over 2, comma 1. Pi, comma 0. And then we have 3 pi over 2, comma negative 1. And then you'll notice if we connect all of those dots that we get that smooth blue curve for the sine curve. Now, I was telling you that once we go around the circle one full time and then start around the circle again, we're going to get the same values repeated. Well, let's take a look at this sine curve so I can show you exactly what happens relative to that. So if I pick that section that I talked about where we started at 0 and went all the way around the circle to 2 pi, we would trace out along the unit circle this graph right here. Well, once I get to here, what's going to happen is those same values will repeat themselves. In other words, this graph will start up just the same way. And I can illustrate it by showing you the negative side. Because remember, negative 2 pi back over here would be the same position of 0. So as I start around the unit circle, I would be getting the same values. That is the same curve traced out. So what I want you to notice is that this sine wave that we're looking at, actually from 0 to 2 pi, gives us all the information we need, because after that, it simply repeats that same exact shape. Notice that the domain for the sine curve is all possible values of x. That is, all real number values. That's the domain. Because we can plug in any value that's a real number. Well, what about the range? Well, the range, of course, is our y value. And notice that what's happening here, and let me do this slightly differently, that the sine curve never goes higher than 1, and it never goes lower than negative 1. And so the range for the sine curve, the sine values, is that the y value, or sine of the arc length, s, has to be between negative 1 and positive 1. So that's our range. Notice also that we have x-intercepts at 0, pi, 2 pi, that is at the multiples of pi. Finally, I just want to share with you that the sine curve is an odd function.